video we are going to learn how to solve the multiple choice question based on the topic number theory. Let's start with the first question. The greatest common divisor of 220 and 1575 is what? For finding the greatest common divisor, first we need to write the prime factorization of these two numbers. Let's take the first number 220. It is divisible by 2. In that case, we get 110. Then again it is divisible by 2. In that case, we get 55. Now, divisible by 5. In that case, we have 11. As it is a prime, we will keep it as it is. Then, 1575 can easily divide by 5. So, here we have 315. Again, divide by 5. That is 63. Now, divide by 3. 31. As 31 is prime, so keep it here as it is. So prime factorization of 220 is equal to 2 into 2 into 5 into 11, whereas prime factorization of 1575 is equal to 5 into 5 into 3 into 31. Now what are the common divisor between these two one? Only one common divisor, that is the 5. Hence the GCD of these two integers is equal to 5. Next, the least common multiple of the integer 120 and 500. We can take the LCM of these two numbers again with the same procedure but together. Both the numbers are easily divisible by 10. So here we have 12 and in this case 50. Common multiple according to 12 and 50 is 2. So we can write 6, 25. Now, nothing is common between 6 and 25. So, least common multiple of these two numbers is 10 into 2 into 6 into 25. That is equal to 20 into 150. Simplify this. This is further is equal to 3000. So, according to this, option D is correct. Next is, which one is of the following is not a prime number? To identify whether that is a prime or not, we have one result. If we have any number, take the square root of that number and find the primes less than equal to that square root of the number. After that, if any prime divides the original number, it means it is not a prime number. Like in the first case, root of 293. This is equal to 17.11. So what are the primes that is less than equal to 17.11? So prime in this case we have 2, 3, 5, 7, after that 11, then 13, then 17. Now check whether 2 divides this? No. Whether 3 divides this number? No. Whether it is divisible by 5? No. What about the 7? No. With 11? Again no. As well as this number is not divisible by 13 and 17. So it is a prime number. Now 263 square root is near to the 16. So we can say that we will take the primes 2, 3, 5, 7, 11, 13. Check whether any one divides 263. If yes, it is not a prime. If not, it is surely prime number. So in this case, 2 does not divide 263. Even 3 does not divide this number. Even this number is not divisible by 5, 7, 11 and 13. So it means this is a prime number. Take the next number 2047. So this is near to the 45. Now we need to take all the prime less than equal to 45. What are they? That is 2, 3, 5, 7, 11, 13, 17. After that 19, 23, 29, 31, 37, 41 and 43. Check whether any number divides this one or not. You can check it. 23 divides 2047. So clearly C is not a prime number. So rather than checking for all the prime numbers, we just need to check for these one. Next is, which of the following is not a Mersenne prime number? Now what is a Mersenne prime number? A prime number that is of the form 2 raised to power p minus 1. When we have p is equal to 2, what type of integer we are getting in this case? That is 2 raised to power 2 minus 1, that is equal to 3. It means 3 is the Mersenne prime number. What we need? Not a prime number, but we need not a Mersenne prime number. So for p is equal to 3, let's check it what number we have. That is equal to 7. So it means this is also not the answer. P is equal to 4. Can we take this? No, because here p stands for the prime. So we cannot take 4 here. Next integer we need to take it as a 5. So 2 raised to power 5 minus 1, that is equal to 32 minus 1, 31. So next Mersenne prime number is 31. It means 13 cannot be expressed in this form where p is a prime. Hence b is not a Mersenne prime number. Next, what is the remainder when this number is divided by 5? Now we are going to deal with the congruency. How to solve this question with the help of congruency? We will use the Fermat's theorem. Why we need to use the Fermat's little theorem? Because we are dividing by the 5 and it is a prime number. So if we are dividing by any prime number, what we need to check? We will check the base. The base is 3. Now check whether P divides A. If not, we will apply the little Fermat's theorem. According to the Fermat's theorem, it says that A raised to power P minus 1 is congruent to 1 mod P. What does it mean? Means if we take the power of A as a P minus 1, when divided by P, remainder is 1. According to this, A is equal to 3, P is equal to 5. And 5 does not divide 3. It means we can directly apply this result. According to this result, 3 raised to power 5 minus 1, that is 4, is congruent to 1 mod 5. Here we have the power 4, but we need to reach at 28. What we can do, we will increase the power on both sides. What power we can take so that it reach to the near 28 or itself 28. So we can take both side power as a 7. So from here we can write 3 raised to power 4 power 7 is congruent to 1 raised to power 7 mod 5. On the left side, we have 3 raised to power 28. On the right hand side, it is the 1 raised to power 7, that is equal to 1. From here, we have this congruence result, which indicates that 3 raised to power 28 when divided by 5, the remainder is 1. Next, the number of solution of the congruency of this is what? So we need to find the number of solution, not the value of x. For this, we have one result. It says that if we have the congruency of this form, then it has a unique solution if the GCD of A and M, that is the greatest common divisor, divides B. Means B by GCD of A by M is equal to integer. Then definitely it has a solution. Moreover, the number of solution is equal to the GCD of A and M. So in this case, what is the GCD of 3 and 4? That is 1, because nothing is common between these two one except 1. Now whether 1 divides 2 means 2 by 1 is equal to integer? Yes. According to this, we can say that it has unique solution in Z4. Now, what do you mean by Z4? Z4 means collect all the remainders in a set when divided by 4. That is 0, 1, 2, 3. Hence, option B is correct. Taking one more case, the number of solution of congruency 4x is congruent to 3 mod 2 is equal to what? Here, find the GCD of 4 and 2. that is equal to 2. Common divisor is 2. Let's suppose this is equal to D. Now D divides B or a not. Now what is a B? Basically we have this congruency in journal form. We have calculated the GCD of A and M. Now check whether GCD divides B or a not. GCD is 2. The value of B is 3. Whether 2 divides 3 means 3 by 2 is integer. No. So it means 2 does not divide 3. This implies it has no solution. So the total number of solution in this case is 0. Consider one more case. Number of solution of this congruence. Find the GCD of 3 and 8. That is 1. Now whether 1 divides 2, that is 2 by 1 is integer. Yes, so that is equal to 2. It means it has a solution. How many solution? That is 1. Next question is, if the GCD of these two number is written by D and it is expressed by this form for some integer s and t, then what is the value of s and t? It's a very simple. First step is we will find the GCD of these two numbers. So what is the GCD of 6 and 14? 6 can be written as 2 into 3. 14 is 2 into 7. What is the common divisor? That is the 2. So GCD of these two numbers is equal to 2. So we need to write 2 as 6 into s plus 14 into t. Now what value of s and t that is equal to 2? We can select that from the options. So if we take first option, s is equal to 2. So it is 6 into 2 plus 14 into 1. This can never be is equal to 2. For the second case, 6 into 1 plus 14 into minus 2. That is equal to 6 minus 28. Again, that is not is equal to 2. So it means B is incorrect. For the third case, 6 into minus 2 plus 14 into 1. That is minus 12 plus 14. Is this is equal to 2? Yes. So it means option C is correct. Next, the linear congruence 8x is congruent to 10 mod 6 has how many solutions? Again, we need to apply the same concept. Find the GCD of 8 and 6. What is the common between these two one? That is 2. How? 8 can be separated as 2 into 2 into 2, 6 as 2 into 3. Only one divisor that is common, that is 2, and one time. So its GCD is 2. Now check whether GCD divides 10. That is 2 divides 10. Yes, because 10 by 2 is equal to 5. So it has a solution. Now how many solution we have? That is the GCD. Hence it has a 2 unique solution in Z6. Z6 means what are the remainders when any integer is divided by 6. Next, what are the quotient and the remainder when minus 47 is divided by 11? It means we need to apply the division algorithm. According to division algorithm, when minus 47 is divided by 11, what is the quotient in this case and the remainder in this case? Simple procedure, we can pick the options. But make sure when we are picking the option, remainder must be greater than equal to 0 and it should be less than 11. It cannot be a negative. And in each option we have the negative remainders. Hence they all are discarded except B. This indicates B is the correct answer. You can verify this whether minus 5 into 11 plus 8 is equal to minus 47. Yes. So in this case, the key point is you need to remember remainder is always greater than equal to 0. It cannot be a negative. Next case is consider the two statements, which one is true and which one is false. Now according to the statement, what does it indicate? It says that 25 is congruent to 5 mod 4. As per the definition, when we say that A is congruent to B mod M, this is only possible when M is dividing A minus B. Or we can say that A minus B by M is exactly divisible. Second, we can find the remainders. In case both sides the remainder is same, it means they are congruent with respect to given mod. Like in this case, 25 when divided by 4, remainder is 1. On this side, 5 when divided by 4, remainder is 1. Both sides the remainder is same, it means first statement is correct. For the next case, 26 when divided by 4, what is the remainder in this case? That is the 2. Now 3 is not divisible by 4 as it is less than 4. So itself it is a remainder. On the left side we have the remainder 2. On the right hand side it is a 3. Both sides the remainder is not equal. It means they are not congruent. Hence only one statement is true but the second is false. Next question is 2 raised to power 16 mod 7 is equal to what? What we need to find? We need to find the remainder. Whenever we have the expression mod, it means we need to deal with the remainder. So keep in mind, if we have any number raised to power highest power as compared to this, then we are going to apply the Fermat's theorem. How to apply the Fermat's theorem? Here we have the prime number as we are dividing by the 7. It means in this case P is equal to 7, whereas A is equal to 2 because base is 2. According to the Fermat's theorem, if P does not divide A, then A raised to power P minus 1 is congruent to 1 mod P. So in this case, P is 7. 7 does not divide 2. So we can apply this result. This implies 2 raised to power P minus 1, that is 6, is congruent to 1 mod 7. Now we need the power 16 rather than 6. First we can increase this one by taking the power 2 on both sides. On the left side we have 2 raised to power 12. On the right hand side 1 mod 7. Now we need 16. It means we will multiply both sides by 2 raised to power 4 so that on the left side we get 16 but on the right hand side we have 2 raised to power 4 as it is because it is get multiplied by 1. Left side indicates 2 raised to power 16. On the right hand side 2 raised to power 4 is what? 16. Now 16 when divided by 7, what is the remainder? In this case the remainder is 2. So it means this expression is congruent to 2 mod 7. Hence option B is correct. Next, two integers A and B are said to be relatively prime if GCD is equal to 1. When we have the concept of the prime number, it means it has a one property, GCD between two number is equal to 1. And if it is a relatively prime, we are not sure whether A and B are the prime numbers, but surely it is following the property of the prime number, that is the GCD of two number is equal to 1. Next is consider this congruence. This is the congruence A is congruent to B mod M. It means M divides A minus B. Now this relation is what? This relation is a equivalence relation, not a partial order relation. What do you mean by equivalence relation? That is a reflexive, symmetric and transitive. As per the partial order relation, reflexive, antisymmetric and transitive. So remember that congruence modulo M is a equivalence relation but not the partial order relation. Hence option C is correct. The link for the proof of the statement is given in a description. Next, what is the unit digit of this number? How to answer this question? We can answer this with the help of modulo M, where M is equal to 10. As we need a unit digit, basically we need to find 7 raised to power 2022 is congruent to what? Mod 10. Now here we have the composite number. It means we cannot apply the Fermat theorem in this case. We will go with the manual procedure. We will increase the power of 7 one by one. 7 raised to power 1 when divided by 10. What is the remainder? Just write the remainder on the right hand side. That is 7. 7 square. That is congruent to 49 when divided by 10. Remainder is 9. 7 raised to power 3. It means 9 into 7. We are multiplying both sides by 7. So what is the remainder in this case? 9 into 7, 63. When divided by 10, remainder is 3. Now 7 raised to power 4. It means we have taken both sides as a 7. So it is 3 into 7 mod 10. 3 into 7 is 21. When divided by 10, remainder is 1. Once we have 1 here, we can easily approach to this number. How? We can find what is the multiple of 4 nearest to this one. That is a 220. How we will get a 220 here? When I take the power both side as the 505. This implies 7 raised to power 2020 is congruent to 1 mod 10. Now we need 7 raised to power 2022. It means we will take both sides as 7 square. On the left side we have the desired power, whereas on the right hand side 7 square is 49 and when divided by 10 remainder is 9. Hence option D is correct. Next, if x is equal to 48, y is equal to 15, then what is the value of k such that it holds this condition? In this case, we are taking a mod y. It means we are dividing by the y. According to this, it says that a number when divided by mod y, the remainder is x. Whereas on the right hand side, when we divide this number with y, what we have? X as it is because it is a remainder. Whereas when y is divided by y, remainder is 0. Now if the remainder is 0, we can multiply 0 with any of the integer. It means here we can say that k can be any integer. Next, it is given that y is congruent to 63 mod 23 and if y lies between this, what is the maximum value of y? There is no need to simplify this. We will plug the values directly from here. Check it, 199 when divided by 23, what is the remainder? And also check it when 63 is divided by 23, what is the remainder in this case? In this case, the remainder is 17. What about this? In this case, when 199 is divided by 23, quotient is 8 and here we have 184. Subtract this, we get 50. But we need the remainder as a 17. Hence, we can discard this option. Check it for the next case. What is the remainder when 178 is divided by 23? So 178 when divided by 23. Quotient is 7 and here we have 161. Remainder in this case is 17. Hence, B is the correct option. Next question is, what is the value of 9 raised to power 6 mod 7? Again, we need to find the remainder in this case. It means 9 raised to power 6 is congruent to what number when divided by 7? Now we are dividing by 7, where 7 is a prime number. And what is the base? A is equal to 9. Now whether prime divides A? No. It means we can apply the Fermat's little theorem. According to that, A raised to power P minus 1 is congruent to 1 mod 7. So direct result we have, that is 9 raised to power 7 minus 1 is 6 is congruent to 1 mod 7. Hence option D is correct. Next, If the GCD of these two numbers is expressed in this form, then what is the value of m in this case? Firstly, we need to find the GCD of 65 and 117. One procedure is a prime factorization. Right now, I am going to proceed with the Euclidean algorithm. 117, when divided by 65, what is the quotient and remainder? Quotient is 1 and remainder is 52. Now divide the 65 with the last remainder. Quotient is 1 and the remainder is 13. Now again divide 52 by the last remainder 13. Quotient is 4 and the remainder is 0. Once the remainder is 0, whatever the last remainder we have, that is the GCD of the two given numbers. In this case, the GCD of 65 and 117 is equal to 13. And this can be further written as 65 into m minus 70. How to evaluate that? Now to find the value of m, we need to look for the option. According to the option A, the possible value of m can be 4 or 5 because it is an open intervals, so we cannot take the endpoints, and surely m is an integer, that's why 4 or 5. According to option B, it can be 2. According to the option C, 0 or a 1. According to the option D, only 4. Check whether any one of them satisfies this condition or not. Let's check it for the case of 4. When m is equal to 4, what we have? 65 into 4 minus 117. That is equal to 143. This is not is equal to 13. For m is equal to 5. That is 65 into 5 minus 117. Clearly this is not is equal to 13. So we can discard the option A. For the option B, m is equal to 2. That is the only possible case. 65 into 2 minus 117. That is equal to 13. And even we need a 13 here. Hence, option B is correct.